This is your reality check.
Hi everyone, and welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. This is the show for September 4th, 2019, and I'm your host, Darren McKee. With me, as usual, are Adam Gardner.
What's up, Q-Boys?
Christina Roach.
Hey everyone.
And producer Pat.
Hi, checkers.
We have a great show for you today. I'm going to talk to you about Absolute Zero, and then Adam is going to talk to us about fires in the Amazon.
That's right.
But first, how IKEA names stuff. Christina, tell us more.
Today I'm leaning towards the curiosities part of the show. Now, I'm no psychic, but I bet Pat, Darren, Adam, you've bought something from IKEA at some point in your life. Am I right?
Yeah, I'm planning to go later this week.
Yeah, and I'm looking at it right now.
And I know Pat has.
Many times.
Yes.
Yeah.
Now, I know we have many listeners from all over the world, which is super cool and still mind-boggling to me. And considering as of November 2018, there were 424 IKEA stores operating in 52 countries, I bet many checkers have thought, like I have, what the hell is an Ektorp? And is the word Kolbjorn really Swedish for where's that damn Allen key? Now, before I dig in, I really sincerely want to apologize in advance to our Swedish listeners for any inevitable pronunciation gaffes, because this language is really, really foreign to me. Now, according to its wiki entry, IKEA is a multinational group of companies that designs and sells ready-to-assemble furniture and appliances and home accessories. It was founded in Sweden in 1943 by, get this if you didn't know this, 17-year-old carpenter Ingvar Kamprad. That's what he was doing at 17. Now, IKEA is an acronym consisting of Kamprad's initials, and the first initial of his hometown, and the first initial of a farm he grew up in, which I will not begin to try and pronounce right now. Fun facts. Germany is IKEA's largest market as of this article, and the first IKEA store in North America opened in Dartmouth, Nova Scotia in 1975. Now, I became interested in covering this after coming across a Business Insider article from February, which breaks down the meaning behind IKEA product names. The article says they have over 12,000 products, and it's actually really fascinating to learn the origin of the naming system. Founder Kamprad, who passed away in January 2018, he's the guy who came up with the system. Kamprad had dyslexia, a learning disorder that can make reading challenging. And as a result, he had difficulty remembering the order of inventory numbers, so he came up with this simplified system, naming each product after a specific Swedish word. And this varies depending on the category of product. Oh, and in case you're curious, like I was, I read that IKEA uses the same product name in all markets around the world to make branding and managing inventory more seamless.
Oh, that
makes
seems
sense.
really convenient.
Oh my gosh, so smart.
Yeah.
Now, a 2018 Business Insider podcast, Household Name, cites a retired IKEA product developer named Jan Alsen, claiming Kamprad's sister oversaw the naming process and was responsible for curating a database of names when the system was first introduced. This is what she says about the sister. Getting a product name past her was like taking an exam in school. So I take it she was a pretty tough cookie. Now, the database is now digital, which makes sense because it's 2019, but how does it work? Now, I'll rattle off a few examples that writer Ann Keto breaks down in a Quartz article. Side note, since the founder is Swedish, many of the names are Swedish words and places, but there are also a lot of products named after places in Norway, Denmark, and Finland. Bathroom items are names of Swedish lakes and bodies of water. Bedroom and living room furniture, Norwegian places. Bookcases are professions and Scandinavian boys' names. Bowls and vases, Swedish place names, adjectives, spices, herbs, fruits, and berries.
Sounds like they just kept having to take more categories there because they had a lot of them.
Desks and chairs, Scandinavian boys' names. fabrics and curtains, Scandinavian girls' names, outdoor furniture, Scandinavian islands, lighting, I found this one interesting, units of measurement, seasons, months, days, shipping, and nautical terms, and Swedish place names, and then sofas, chairs, and dining sets, all Swedish place names.
And when I hear that, I think it's like, this is a system that works for one person who created it. Pretty much, yeah. And it was like, it's completely intuitive. Don't you all see how it works? And everyone's like, no, can't we use numbers?
Well, they still do use numbers, but they do, the product names are front and center, as you guys know.
Yeah, well, it's convenient because, you just write down the name on your little piece of paper, but you can write down the little number, or it'll say where it is, usually on the little piece of paper. And these days, you just take a picture of the tag. I find everything works so well in IKEA. It's like they've kind of thought of, here's like a super redundant way for you not to lose what you're looking for, right?
Although, Gossip Girl here, I did read that they are looking at potentially, at least in one store, phasing out the maze.
Oh,
that they don't think it is in line with new trends in shopping and how people enjoy their shopping experience. And I thought that's fascinating because that's one of the things that are it's just in the fabric of going to IKEA, right? Now, they are known to go rogue and break these rules for naming stuff once in a while. They'll name some products with more functional names now, like the Krosse Spice Mill, which means to grind. Or in the instance of IKEA's number one selling product, I bet you guys can guess it. Every college dorm room probably has at least one.
The Billy bookcase?
Yes, the Billy bookcase, which was named after an advertising manager named Billy Lichtjehal. Now, technically, that's a Scandinavian boy's name, so I don't know. I think they're still okay there. So there you go. That's just something fun to think about the next time you're winding your way down the maze that is IKEA.
It seems to me they could have as easily said product numbers between 0 and 1,000 are bookshelves. Product numbers between 1,001 and 2,000 are kitchen items. It seems almost their brand now as opposed to anything functional.
Absolutely.
Yeah.
Yes. Yeah.
So to a foreign consumer, you look at it and it almost seems like these are just fake names they use to impress us, because it's just like everything's got this unique foreign sounding name. And I wouldn't have been surprised if you just said like, these aren't even real Swedish words. They're just like
made up.
Right.
Vowels and consonants put together to make it sound foreign. But like to know that it makes sense to them, but to us, it still kind of has that foreign kind of kitschy appeal. And it's still, you can look at a name and you can semi-remember it. So it works really well. Obviously, they've had enormous success. But it's
true. Yeah. Those umlauts don't sell themselves. Thanks, Christina. And now we turn to Absolute Zero. It's still the summertime here in Canada, so what better time to talk about the coldest thing ever? No, I'm not talking about your ex and how they handled your breakup, even though you might think of them as an absolute zero. Bam! But I'm talking about the lowest limit of the thermodynamic temperature scale. I think many of us know this is 0 Kelvin, and it's supposedly when matter doesn't move anymore. But is that true? Is any matter at absolute zero? Also, I'm no big city chemist or superconducting physicist, so this will be an overview. First, what's temperature? Well, Nellie may tell us that it's hot in here, and we often use temperature as if it were a definite thing, but it is a higher order concept describing the motion of matter. Quoting the lovely Wikipedia, roughly, the temperature of a body at rest is a measure of the mean of the energy of the translational, vibrational, and rotational motions of matter's particle constituents, such as molecules, atoms, and subatomic particles.
You're going to break that down, right?
Well, I'm just going to keep saying more things. Full variety of these kinetic motions, along with potential energies of particles, and also occasionally certain other types of particle energy in equilibrium with these, make up the total internal energy of a substance. Internal energy is loosely called the heat energy or thermal energy in conditions where no work is done by the substance by its surroundings or by the substance on its surroundings. It's the idea that if something's somewhat in isolation, it's not doing anything and something's not being done to it, it still has motion and energy related in many different planes, for lack of a better phrase. Like there's vibration. You can picture what that is. Rotation is a different type of thing. So there's still energy latent in the object, and it's somewhat moving around, if that helps you think about it.
Yeah.
So if the matter's constituent particles don't move at all, there would be no energy, and thus zero on the temperature scale. That's sort of the question. And that's close to how it is. Absolute zero is when the fundamental particles of nature have minimum vibrational motion, but not actually no motion, because the particles still retain quantum mechanical zero-point energy-induced particle motion. You may ask, what is zero-point energy, aside from the crazy thing other people talk about on the internet? Well, quantum field theory says that the universe can be thought of not as isolated particles, but as continuous fluctuating fields, both matter fields and force fields, like Jedi. And this means that there may still be some motion. There's not consensus on exactly how all this works. And as I talked about quantum mechanics earlier, I'm not going to say much more about it. But that's the idea.
So you're saying that absolute zero can be attained, but there will still be motion? Or is it that it can't because there is motion?
Actually, I wasn't saying either of those things.
Okay.
I was saying that absolute zero means there's no energy and thus no temperature at all. And what I'm trying to say is quantum mechanics implies that there is always some sort of energy latent in the existence of matter due to fluctuating energy fields.
Okay.
But other types of energy may not exist.
But of course, this is all theoretical because nothing can reach absolute zero.
Yes, that is what our current understanding, and I'll get into some examples where we've come pretty close a bit later.
Mm-hmm.
Darren, my question simply was, do you think you could say quantum mechanical zero-point energy-induced particle motion 3 times fast?
Quantum mechanical zero-point energy-induced particle motion, quantum mechanical zero-point energy-induced particle motion, quantum mechanical zero-point energy-induced particle motion.
Nice.
That's not bad.
Nice. High fives.
Getting back to the realm of the very cold, I like thinking about absolute zero because in our everyday experience, you can just make something colder. In fact, we probably don't give it a second thought. I'll just put it in the fridge. I'll put it in the freezer. It's only when you ask yourself, but how would I make something colder than my freezer on max, do you get a glimpse of a different type of problem. The average temperature of the universe today is approximately 2.73 kelvins, or minus around 270 Celsius, or minus 454 Fahrenheit. So you can't actually just put something in space either. It's still not cold enough. Quoting Wikipedia, the laws of thermodynamics indicate that absolute zero cannot be reached using only thermodynamic means, because the temperature of the substance being cooled approaches the temperature of the cooling agent asymptotically.
Sure.
This makes sense. An asymptote is, picture a line and a curve going towards the line, never quite reaching the line, and that's an asymptote. So it becomes closer and closer, but never quite getting there. This makes sense. It's not like we have some absolute zero ice cubes we can put on something to cool it down. As Pat might say, it's complicated. Well, how complicated? People have worked for many years to cool things down. By 1845, Michael Faraday, the good old Michael Faraday, had managed to liquefy most gases then known to exist and reached a new record for lowest temperatures by reaching minus 130 degrees Celsius, or 143 Kelvin. Faraday believed that certain gases, such as oxygen, nitrogen, and hydrogen, were permanent gases and could not be liquefied. But decades later, 1873, Dutch theoretical scientist Johannes Diederik de van der Waals demonstrated that these gases could be liquefied, but only under conditions of very high pressure and very low temperatures. And then you have people later like James Dewar and Dutch physicist Heike Kamerley-Ons, correct me on the pronunciation of that one, taking on the challenge to liquefy the remaining gases hydrogen and helium. In 1898, after 20 years of effort, Dewar was the first to liquefy hydrogen, reaching a new low record temperature of minus 252 Celsius or 21.1 Kelvin. His rival was the first to liquefy helium. It's the idea that someone spent 20 years liquefying hydrogen. So you don't have to. And how often do you think about him? The lives of others fascinate me.
Yeah.
So as Pat said, absolute zero cannot be reached, although it is possible to reach temperatures close to it through the use of cryocoolers, dilution refrigerators, and nuclear adiabatic demagnetization, which everyone knows what that is, so I'm not going to explain. Few highlights of how cold we've managed to get things. The current world record was set in 1999 at 100 picokelvins. Pico is in between nano and femto. Nano is 10 to the negative 9. Pico is 10 to the negative 12. Femto is 10 to the negative 15. Or, 10 billionth of a Kelvin by cooling the nuclear spins in a piece of rhodium metal. In 2017, the Cold Atom Laboratory, they had an experiment developed for the International Space Station. This instrument will create extremely cold conditions in the microgravity of the ISS, leading to the formation of Bose-Einstein condensates that are a magnitude colder than those that are created in laboratories on Earth. in a space-based laboratory up to 20-second interaction times as low as 1 picokelvin. Temperatures are achievable, but it could lead to an exploration of unknown quantum mechanical phenomena and test some of the most fundamental laws of physics. Why that's stated in the future? Because it hasn't happened yet, it seems. What about naturally occurring? Well, in February 2003, the Boomerang Nebula was observed to have released gases at a speed of 500,000 kilometers an hour for the last 1,500 years. This has cooled it down to approximately 1 Kelvin, as deduced by astronomical observation, which is the lowest natural temperature ever recorded. Can we go colder than that? What would that even mean? Anything colder than absolute zero? Not in a conventional sense, even though we were talking about the peculiarity of absolute zero. Something I found on the internets believe they've actually found such a thing, some experimenters, although it is confusing. Here's a quote. The gas is not colder than 0 Kelvin, but hotter. It is even hotter than at any positive temperature. The temperature scale simply does not end at infinity, but jumps to negative values instead.
What?
Yeah, that was a quote from one of the guys doing it. I'm like, let me Google around. So then that didn't make much sense to me. I found an article on WiseGeek, which helped a little. And here, WiseGeek, they said, absolute zero is defined as the lowest temperature possible on the Kelvin scale. So far, so good. But in early 2013, scientists were able to create an atomic gas in a laboratory that actually reached sub-absolute zero temperatures.
What?
Yeah. This temperature is equivalent to minus 273.15 Celsius. Physicists in Germany cooled quantum gas in a chamber and used magnetic fields and lasers to rearrange its atomic particles. At positive temperatures on the Kelvin scale, atoms attract each other and remain stable, but with these changes to the atomic arrangements, the particles repelled each other and thus were theoretically considered to be at a negative temperature on the Kelvin scale. One more before we talk about it. This is from Wikipedia. On the 3rd of January 2013, physicists announced that they had created a quantum gas made up of potassium atoms with a negative temperature in motional degrees of freedom for the first time. This is what I meant getting to the heart of what things mean. Typically, certain things attract each other, and now if they repel each other, they're not quite the same thing. So there has to be some other explanation of what's changed and what's different. And they were suggesting, the original researchers, that they've actually gone below absolute zero. And I think the other phrase of a negative temperature and motional degrees of freedom, that would be the repelling versus the attracting, makes a bit more sense, even though it does highlight complexity everywhere. Finally, and your age will depend on whether you think of Paris Hilton or Kimmy K, absolute hot is a theoretical upper limit to the thermodynamic temperature scale, conceived as an opposite to absolute zero. Again, like, well, couldn't you just make something hotter? Yeah. Surely there's some filter on Instagram. Contemporary models of physical cosmology postulate that the highest possible temperature is the Planck temperature, which has the value of, we'll just say 1.416 times 10 to the 32 kelvins. Above 10 to the 32 kelvins, particle energies become so large that gravitational forces between them would become as strong as other fundamental forces, according to current theories. There is no existing scientific theory for the behavior of matter at these energies. A quantum theory of gravity would be required. The models of the origin of the universe based on Big Bang theory assume the universe passed through this temperature at about 10 to the negative 42 seconds, 1 Planck time, after the Big Bang as a result of enormous entropy expansion. And that was also from Wikipedia.
And before that Planck time?
Well, that's, again, laws of physics kind of break down.
Yeah.
And what things mean, we don't quite know. So, yeah, again, what is temperature? What is heat?
Oh, yeah.
What has meaning? I just thought it was really interesting to think about these concepts because, and every day, hot and cold are pretty obvious.
Yeah.
And then you start pushing it to the extremes. You're like, well, can't you make something colder? Well, can't you make something hotter?
We live and exist in such a narrow range of temperature, right?
Yes.
So obviously, even anything that remotely approaches absolute zero would be instantly fatal to us.
It's true. The minus 40 in Ottawa isn't that pleasant, but it's not as bad as minus 273.
Yeah.
And now we turn to Adam to talk to us about fires in the Amazon.
That's right, Darren. You may have heard that the Amazon rainforest is on fire. This has made many headlines and quite a bit of buzz on social media over the past few weeks. Based on the news, it would seem like the fires are truly unprecedented. But what if I told you they weren't all that unusual for this time of year?
What?
I know that there's fires this time of year, that's not unusual. But the way it's being covered, it does seem like it's worse. So there you go.
This is the only time I can think of that there was news coverage of the Amazon rainforest on fire.
Yep. That's how I generally feel as well. Now, first, a bit of background on the Amazon rainforest. Now, rainforest in general is a dense area of forestation which has a lot of rain. Now, when I was young, people mostly called all of these jungles, though this is a less specific term, and rainforest describes a more specific type of jungle or forest. So I guess I used to have the idea that they just kind of rebranded jungles to rainforests to make them a little more like hippie friendly or whatever, but it does really mean something. So it's not just a word that someone made up. Well, all words are made up, but it does mean something.
I agree. Well, actually, all words are made up.
They're all made up. It's all part of our intersubjective reality. It is real in a sense, and that's fine.
Oh, wow.
Activism to save the rainforests have existed for decades. There was a big focus being put on it during the 1990s, and this was a bit of a fad. Not to say that there wasn't any legitimacy to the concern, but it was like a big popular thing, and it was kind of the thing that people were into at the time. Now, we seem to be reliving an unusually high concern for the rainforest, and this is very recently. The Amazon rainforest spans many countries, though 60% of it is in Brazil, and that is the country that's been getting the most attention for these fires. Most attention, the most flack, the most criticism, whatever you want to call it. So what's causing these fires? Now, climate change is being thrown around, and though climate change is probably the greatest existential risk of our time, until the machines take over, it isn't necessary to explain this particular phenomenon and what's been going on this summer. The interior of the rainforest was pretty much intact until the 1960s, at which point a slash-and-burn method was used to clear out farmland, so certain portions of it were cleared out by large numbers of farmers. As the name suggests, this involves chopping down and setting fire to vegetation in order to create an area which is ready to plant crops. The most common use of this land is pasture for cattle, so they'll plant, some grass. Cows will eat it, kill the cows, sell the meat. Everyone makes money. Now, to further complicate things, the soils in the Amazon rainforest will only produce for a short period of time, losing fertility and potentially being overrun by weeds. Basically, it's surrounded by this jungle area that's got a lot of vegetation in it, so that spreads back in. So what's the simple solution? Instead of maintaining this land, move on to a new area, slash and burn, replant, repeat. Success. Now, the end effect, unfortunately, is deforestation of the rainforest, which is very bad, though some specific claims, such as the Amazon producing 20% of the Earth's oxygen, are just objectively false. We can get into that maybe in another segment, but most of the oxygen on Earth comes from the oceans.
Yeah, that stat was everywhere. Everywhere I looked, people were spewing that.
I think we actually had a listener write in about the Amazon rainforest being the Earth's quote-unquote lungs at 20%.
Right.
So, are there more fires this year? Or did they just get out of control? Or what's going on? Now, Brazil's president, Jair Bolsonaro, is getting a lot of blame for this year's fires due to his lax environmental policies. Reading some articles, it seems clear that this is a big new issue. The New York Times states, and I quote, "From January to July, fires consumed 4.6 million acres of the Brazilian Amazon, a 62% increase compared to last year." USA Today, and I quote, "There have been more than 74,000 wildfires across Brazil this year, up 85% over the same period in 2018, and about 40,000 of them are burning in the Amazon, according to the country's National Institute of Space Research." So these are numbers. I'm not disputing these numbers. Take these quotes for what they are. It sounds like there's been a massive jump from what there was there before. So let's see what NASA has to say. And I quote from the NASA Earth Observatory. "As of August 16th, 2019, an analysis of NASA satellite data indicated that total fire activity across the Amazon basin this year has been close to the average in comparison to the past 15 years.
No.
Yeah, so that one kind of blew my mind when I originally saw that. Now, this is based on the Global Fire Emissions Database, so I drilled in to see what they were saying about this. Maybe make sure there wasn't some particular spin being put on it. Mm-hmm. Now, this isn't terribly specific. They're saying close to the average. But it was certainly surprising, given the coverage. Even to be able to say that it's in the ballpark was shocking. So digging in, there's an update on the Global Fire Emissions Database from August 29th. That's a little more recent, so we can get a better idea of what's going on. And the update states that based on two metrics that they use, the 2019 fire season has the highest fire count since 2012. Now, one of the metrics goes back to 2003, and the other started only in 2012. So obviously that one that just started in 2012 means the highest yet. But the one going back to 2003, all considered, it's not the worst ever. It is specified that the fires are more intense this year. Now, going back to 2003 and comparing droughts, we can see that 2019 is not an extreme drought year. So an environmental explanation for the fires doesn't quite fit the bill. There have been heavy droughts in recent years, and these are due to climate change, but this year wasn't necessarily one of them. Now, when we're talking about climate change, the flip side of that is there is a negative impact on climate change because of the burning and the smoke and all sorts of things like that. Now, increases in deforestation are also high compared to recent years, but not higher than they were in the 2003 to 2008 timeframe. So there's a lot more slash and burn, a lot more deforestation going on in that timeframe. Now, details and graphs are in the links in the show notes at trcpodcast.com. So they are a bit high recently compared to recent years, which some news sources play off of, such as a graph from the BBC showing numbers of fires since 2013. And the title of that graph states, "This year has seen more than double the number of fires in Brazil since 2013. Well, 2013 is the lowest in the graph, but there isn't an increasing trend. So it's not like, you just take that quote for what it is. It either means something's going crazy this year, or there's been a gradual increase, and this is how bad it's gotten since 2013. But if you look at the graph, it's really up and down, but you're taking your frame of reference as the lowest point on this graph. It's a little dishonest. So this explains all the articles showing numbers that are comparing 2019 to 2018. Again, it's playing with the numbers a bit because 2018 was a year where the fires were pretty low. So when you present it like that and you say, oh, they're up 60% using this metric, or they're up 85% using this metric, it sounds shocking, but you can say, oh, well, if you compare it to 2016, it's not really up that much. Or if you go back even further, it's down. So you can play with the numbers to try to get the point you're trying to make across. And I'm not trying to downplay it. I'm just saying you can put a spin on it. So further, a lot of viral content shows photos that aren't even from this year. So a tweet which got 500,000 shares on Twitter contains photos from 1989 and 2012. So the Amazon rainforest is burning, and while this seems like a shocking, once-in-a-lifetime sort of tragedy that we should all be tweeting about, it's sort of an annual thing. And this year's fires are pretty bad compared to the last few years, but they're not the worst in the past 15 or so. Should you care? Well, sure. You probably should have cared about it for the past 50 years, but that's not to say that you'll have much success in doing anything about it. But that's kind of another subject, potentially for another episode.
Didn't Neil deGrasse Tyson get quite a bit of heat for tweeting something about this?
Something about the similar point that Adam's trying to make,
Yeah.
which was also what I was arguing about on Facebook when I was posting this stuff. It's right that whether it's happened before and there's a trend line is independent of whether it's good or bad overall.
Yeah.
But as you said, maybe it's always been an issue, and maybe there should have been policies in place to address why local people might feel the need to do this. And if we don't want them to do it, then have them compensated in some way. It could also be the case that there is a different reason for this increase this year compared to last year. It's like, well, why would that be? Why would it go down so much last year and go up so much this year? And, you could say, well, there's random patterns and fluctuation and so on, but maybe there are specific reasons linked to political policies, or maybe they aren't. And in that case, there may be room for activism in one domain or another.
This has become like a big topic of conversation at the G7 when it's not new. So even politicians are getting swept away with this kind of narrative and the new popularity of it.
And they're somewhat responding to constituents.
Yes.
They care, and then they have to say something. There's also the thing where, the leader of Brazil insulted Macron's wife. So there's the whole other layer of, A, they don't like the guy in the first place, the Brazilian leader, and then B, there's other political interpersonal games that people play.
Yeah. This is maybe getting a little too deep into it too, but the people doing this, there's hundreds of thousands of poor farmers who are trying to feed their families, and this is the best way they have to do it. So how do you counter that? People are like, boycott beef and boycott soy. So now everyone's more poor, or now, what's that going to do? Are they going to slash and burn more because they can't afford to keep up? It's complicated. And the solutions are complicated, right?
And this is definitely a running theme. So if we look at North America, we completely destroyed a lot of the natural resources in order for people to become, we're somewhat wealthy in North America.
Yep.
But then we got a hard time when someone else tries to do it because they're poor.
Yeah.
Of course. We're still doing it now.
Sure.
Yeah.
And it's like pollution in developing nations, right? We got there that way, and now they're getting there that way, but it's becoming a more global problem. So,
But still let us buy all the products that they're making.
well, yes, if I can get them at the dollar store.
Thanks, Adam. And thanks for joining us once again, listeners. Christina talked to us about how IKEA names their products, and there are reasons and various categories. It may not be intuitive to us, but they were to its founder and namer. I talked to you about Absolute Zero, how things can get really, really super cold, but not quite all the way cold. And finally, Adam talked to us about fires in the Amazon, which could still be a problem, but are probably not quite getting the correct interpretation in the media coverage. Until next time, think better, tack better.
Peace out, Cuboids.
Stay classy, not smart-assy.
We'll talk to you next week, everyone.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at TRC_podcast.
Thanks.
In Norway, Denmark, and Finland. Woo!
Take that again.
Want to try that again, Smokey?
Some,
Yeah.
some robotness.
Let me tell you, sweetie, they've been naming products my whole life.
I'm Ben Lash's wife.
Nellie may tell us it's hot in here. No one laughed at that.
So I imagine that would be the listeners would be like, what was that a joke? Like, and so I wasn't looking necessarily for laughs, even though I thought people listening
And
at
then
home
they're
might
like,
find
why
it
did I
funny."
just start taking off all my clothes?
Yeah.
Yep.
Quoting Wikipedia again, the laws of thermodynamics. Let me try that again. Quoting Wikipedia, the laws of thermodynamics. Yeah.